Saxon Algebra 1, Lesson 95. This is a fun lesson because it is basically an art project. We're going to do lots of drawing and just look at a few numbers. There's not a lot of calculation in this. Graphs of nonlinear function. Okay, we have talked about a linear function a lot, even though we haven't really called it that. It is this. We've called this the equation of a line, right? That's normally what we say. But we can also call that a linear function because it is a function. It is a mapping between values for x and values for y that creates a line, right? But some functions make different shapes, and that's what we're going to look at today. Graphs, shapes of functions that are not lines. All right, let me show you what that looks like. Well, I guess I need to make him big-ish. Draw 4 pluses on your page. You don't have to make yours quite as big as mine. I'm going a little ape. But I want to make sure it's easy for you to see. Okay, the first one has a shape that looks like this. It's a U shape. It's exactly the same on either side of the y-axis. Mine's not perfect. It is gradually going out, but it makes this nice rounded shape down there. This is called a quadratic function. And if you wanted to write it in its simpler form, that would be the f of x equals x squared. A quadratic function always has a square in it, okay? This, ooh, that one's fun to draw. It's a swooping shape. It crosses through the center perfectly. This is always slightly going out. This is always slightly going out. It doesn't go straight up. Mine looks a little too straight up. And this curve is exactly the same as this curve. This is called a cubic function. And we get this shape when we take something to the third power. It makes this shape. All right, 2 more. This one starts at the center and it goes like that. It's increasingly going up. It should probably curve a little bit more. This is a square root function. And in its simplest form, we would say that it's equal to the square root of x. And then our last one is one of the most satisfying, a line that goes from the center right through the middle. These two halves are the same, and then it does the same thing over here. Right through the middle, so it makes like 2 perfect triangles. This is an absolute value function. Whoops. And we say that the f of x equals the absolute value of x. Okay, so what I want you to take away from this is that when we look at these 4 other functions, quadratic, cubic, square root, and absolute value, all ideas that we're used to. We've never really thought of them as functions before, but we could. You can graph them, and they make very distinctive pictures. Now what we're going to do is we're going to look at subtle variations within each of the 4 types. We're going to look at how, like, what happens if you want to shift it up or down, or side to side. What if you want to take this and turn it upside down? How would you change the basic equation to do that? So we're going to look at each one of these four in a little more detail and talk about how you can change the basic equation to shift the picture ever so slightly. So first we want to talk about quadratics. We're going to take them in the same order that we looked at them before. So here's our quadratic function. And remember, that's where we're squaring it. Quadratic and squaring, put those two ideas together in your brain because they belong together. All right, now what John does is he wants us to draw four pictures. And in this first one, he's going to draw the basic one that we started with and show you that this is, again, just your basic x squared. Now, in this next one, what he's going to do is he's going to say, let's move this out 3 units to the right on the x-axis. Of course, that is the point 3. And let's put it here instead. Again, my parabolas are not perfect, but you get the idea. How would we change this equation or function? How would we change it to represent that? That's how we would write the equation for this parabola. Look at that. It's x minus 3, but we're actually moving it 3 positive units on the x-axis. So the sign is the opposite of the way we move it. That's weird, right? Now, what if we wanted to move it 3 units down on the y-axis and have it look like this? How would we change the basic one for that? I'm going to put the minus 3 on my graph too. Okay, this looks different. To shift it on the x-axis, we put the number in parentheses right close to the x, and we use the opposite sign. Here, we're putting the number separate from the x, right? There's the x. We're separating it. And the sign matches the place on the y-axis, right? So here the sign was opposite. Here the sign is the same. Here the 3 is scooched up right next to the x. Here the 3 is separate. It's tacked on at the very end. Oh, that's some interesting differences, isn't it? And what you'll see is as we do the different kinds of functions, these patterns will hold. Okay, what if we wanted to do this? What if we wanted to take our starting parabola and just flip it down? Pretend it's perfect. That's not perfect. Look at how this works. A minus sign flips it down. Okay, so we started with our basic, we shifted it to the right, we shifted it down, and we flipped it upside down, and we looked at how the equation is affected by all of those. Let's see what happens when we fool around with the cubic functions. Again, let's draw 4 plus signs. And in the first one, we'll put the basic cubic function that we drew before. And we said this is equal to x cubed. Don't let this f of x thing flip you out. We could just as easily write y, but then it wouldn't be function notation and we wouldn't feel half as smart. All right, so what we want to do is we want to shift. John, for whatever reason, chooses just to go 2 times this time. We're going to shift our cubic function so it goes here. Pretend it's perfect. And what do you think happens? This is going to become same thing. We put the change right up close to the x, and the sign is the opposite. We moved it positive 2, but this says negative 2. Okay? Now what about this? This time we want to shift it down 2. The sign matches, and the adjustment comes separate from the x cubed, right? Here we put it right, oh, this should be 3, sorry. Here we put the 2 close to the x. Here we keep the 2 away from the x. And now our last one, and this is kind of hard to, it takes a little bit of a mind bender. This is the reverse of that. It's as if you imagine that this is like a spinner and there's a pin holding it right in the middle, take this and pull it up, and that brings this one down. And this is the picture that we get. And we say this is the f of x equals minus x cubed. So once again, a minus sign flips it upside down. All right, so we're seeing a pattern in how these shifts are reflected in the equations. Let's look at the other ones. We're halfway done with the variations. And then we have a couple, once we get through all these variations, then we just have a couple problems to look at. Square root function. Again, draw 4. See what I mean when I say this lesson is an art project? Okay, our basic square root function looks like this, and we said it was an equation that looks just like that. All right. Well, let's try moving it this way on the x-axis this time. This is minus 2. How would we write this? So the pattern kind of holds. We bring the change right up close to the x, and we use the opposite sign. We moved it to the negative 2, but this says positive 2. Okay, so the x-axis continues to keep its adjustment close to the x and opposite sign. What about if we wanted to go up 2? This is positive 2. This equation the 2 is not up close to the x. The 2 stands alone, and this is positive 2, and this is positive 2. The sign stays the same. I want to introduce a name for these shifts. That John does not introduce. Well, yes. This is called a horizontal translation. Because we're moving it along the horizon, if you will, the horizontal line. This is called a vertical shift. Vertical means up and down. Oh, shifter translation. You can use either word. S-H-I-F-T. I wrote a swear word in the math lesson. Shift. Okay, so we can use these fancy names, but the idea remains that when we're moving it along the x-axis, we put the number up close to the x and we use the opposite sign. When we're translating on the y-axis, we keep the number separate from the x and we use the same sign. Okay, last one is the upside down, right? What if we want to start in the middle, but we want to go that way instead of up? Well, you probably guessed it. Minus on the outside, not on the inside. Okay? So this is, we call this flipping so far. And then the last one. Oops. Fresh book. And this is the absolute value. Functions. Again, draw 4. The basic one looks like this. F of x equals the absolute value of x. And then let's go back to moving it 3 units like we were in the beginning. If we move it, if we do a vertical, no, this is a horizontal translation, then you know what we're gonna do. We're gonna bring the change right up close to the x, and we're gonna use the opposite sign. This is positive 3, so I'm gonna say negative 3, and the change is gonna go right close to the x. If I want a vertical shift, let's bring it up 3 points. This is where I keep the x by itself, I put the number separate, and I make the sign match. So this would be plus 3, right? With horizontal shifts, the sign is opposite. With vertical shifts, the sign stays the same. And then our last one is if we want to flip it upside down. And this is accomplished with a minus sign. Okay, so we now know how to do 4 basic types of functions, and we know how to write each one 4 different ways. As the base function, with a horizontal shift, a vertical shift, and flipping. We can accomplish all 4 of those moves for each of the 4 shapes. All right, now let's look at the examples. I'm going to show you these in the book because there's a lot of drawing. 95.1. The graph of a quadratic function could resemble which of the following graphs? The key word there is quadratic. We know the quadratic is the U-shaped one. So just glancing at this, we go, well, it's got to be B. Only B looks like one of the graphs, right? So we know quadratic is a U shape. Let's carry on. Given the equations of the following functions, identify the function whose graph, okay, blah, 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 blah. They want us to match the equations to the shapes, okay? So let's figure it out. The first one is x cubed plus 1. Okay, so we know that's a cubic function, and that's shape B. G of x is absolute value. Okay, absolute value is, I call this a flying geese one because it looks like geese flying in formation. This one's a square root. It's kind of like a Nike swoosh. And then this one is x squared, so that's the parabola, okay? So when we're just matching like this, We don't really have to worry about all this, the other information. We're just looking for the basic pattern of those first 4 functions that we looked at. Okay, we're not looking at shifts right yet. Shown below are the shapes, and then here are the equations. Okay, so this time we're just matching in the opposite order. This we know is a quadratic, so it's squared. There it is. This is cubic. There it is. This is absolute value, and this is square root. Okay, so John's just trying to drive home the basic shape that we covered in the very beginning. He's not talking about any of the shifts, even though he's showing them. We don't really have to worry about it because we can't see exactly where these are positioned on a graph, right? We're just identifying the basic shape. So you do the same in the practice, and lesson 95 is complete. Yay. Goodbye.